Hi, good afternoon, everyone. So, welcome on board to our Thursday Lunch and Learn. My name is Marcia. I'll be the facilitator this afternoon. And today we're going to talk about the hacking Windows. My apologies for earlier. Some reason the event was placed on my calendar in a different time zone. So my apologies. So I'll place you online with Andy to walk us through the hacking Windows. And I'll have, if you do have any questions, feel free to place them in the chat. Even though I'll be on the background, I'll keep eyes on it. And any questions we can place to be responded in real time.
Okay. I'm here. Okay. Okay. I can see myself. Okay. Just need the presentation. I just need to add the presentation. Okay, perfect. Marcia, thank you. Okay. So yeah, there was some strange confusion with the time zones. That's okay. Is it okay to start? Should I start? Oh, is this recording already? I'm not sure.
Yes, we can enter the stream. It's going to be recorded on our YouTube channel. You may go ahead.
Okay, perfect. Thank you very much, Marcia. Okay. Okay, so welcome everyone. My name is André Melancia, and let's have some strange session about security on Windows. Because if I say that we're gonna do hacking, I can go to jail. So I definitely don't want that. Okay, this was my lovely cat, and this is me. I usually do these kind of crazy sessions a bit all over the world, and a lot of them here in Cloud Lunch and Learn, and many of them in person, but I always try to make them as complicated as possible in terms of crazy things. This one is a bit less crazy, a bit more practical, and I think most of you already know what the screen means. This one specifically is green. Why is it green? Well, because this is the Windows Insider build. Now everyone knows that a blue screen of death is supposed to be blue, but now they are black, which is very, very strange. But the green one is for insider builds. Now, if you want to actually change the colors of this, it was possible for you to go to some ini file and to do some strange changes. So if you search online, it is possible to change. But recently, I think it's not possible anymore. But then again, this is not the priority to change to a crazy different color every time your Windows crashes. You really don't want it to crash, but okay. So let's give it a try and have a look at some of the things we're going to cover in this session. Now, the session is mostly about doing two different things. It's not just Windows. There is some Linux involved here as well. But the objective here is to consider two different things. It's about optimizing and it's about security. Both actually go very well together, because when you consider that many things are let's say when you talk about things like using a CPU, assembly things, hardware things, etc., that actually applies to both security and optimization. So if you know how to do one, you typically know how to do the other. It's a good way to actually learn about some of these things by learning things like assembly, by learning things like electronics, and understanding how CPUs actually work internally. I'm not going to go to that level, uh, but that kind of knowledge actually helps you optimize things, like optimize a database to make sure that you can run it faster because you know what the tricks are. So all of these are things that you can do if you know how the internals of Windows, the internals of CPUs and hardware, if you know the internals of all of these things, then you are on the right track to optimizing things to save a lot of money. If you need to use a server and the server is at 100% capacity, if you optimize it, you can actually save a bit of money. A lot of people that I know actually work on this area of optimization, and they save a lot of money to the companies that hire them. So it's worth it to hire them to actually save money. So you can imagine how that is. And in a world of clouds, the difficult thing is, oh, but it's just cheaper to pay a bit more in the cloud, and who cares about the CPUs? Let's spend some more. Well, there is a limit to that, because after a while you are spending so much more, you need to optimize. Okay, so how do you do it? You can actually solve, I have two screens, by the way. This is something I need to mention. I have two screens. The screen I'm presenting in is, of course, the one I'm going to be looking at, but sometimes some of the demos that I'm going to do, and this is mostly demos, some of the demos that I'm going to do will actually pop up on the other screen, so I will move them. Apologies for that, but it's difficult to manage these kind of things, if I actually have two screens. Okay, so solving slowness things, freeing up RAM memory, because RAM memory is necessary. This computer is 16 gigabytes of RAM, so it could be more, but it's more than enough in most cases if you know how to optimize it. The fragmenting Windows it used to be a good thing when you had mechanical disks, and that made a lot of difference in terms of speeds. Nowadays we have SSDs. SSDs have different logic, so the jumping around between different parts of the disk is actually at the same speed. But if you read from the disk, it's perfectly okay. But if you write a lot to the disk, you have a problem. Ironically enough, if let's say 50% of your activity is to write to the disk, in that case, a mechanical disk will be faster than an SSD, because SSDs are faster at reading than writing, and mechanical disks are the same speed. So those kind of tricks are tricks that are good to know to optimize things. Another one is when you have, there are sectors on disk which are 512 bytes, and then you have clusters which usually in NTFS in Windows are usually 4 kilobytes, so basically 8 sectors. But then you have pages in SQL Server which can actually be different, and extents. So pages can be 8 kilobytes, extents can be 64 kilobytes. And while that is kind of okay, if you misalign them, that could be a problem, because now if you align them and you read 64 kilobytes in one go, or if you have a RAID array and you read them in one go, that is fine. If you have to read half of it and then read the other half of it, you are slowing things down by 50%, okay? So, or actually by half in this case, 50% of something. Depends on how you calculate it. Okay, so this example is actually quite old, probably Windows XP, I can't remember. But 20 years ago, this was a problem, because when you were waiting for copying things, this actually used to happen. Okay, now these internals can be used to hack Windows as well, so as I mentioned, and we are going to see this. Now, the first example that I'm going to do is to hack Microsoft Edge, if that's okay. Now, before I do this, let me just say that I'm not the first one to discover this. This was actually discovered maybe a year ago. This was reported. No one actually cared. It's not a big problem, but it is a problem that can actually be exploited. But the reason I'm showing this is that I presented this session for the first time 3 weeks ago, actually a month ago maybe, in TechEd in Prague, and by that time, 1 or 2 weeks before that, this actually came out saying, look, I'm going to release the information, etc., because no one cares. Microsoft didn't care about me, so I'm going to release it. So I can't remember who the the person was. But I decided to have a look and try to understand, can I hack it? And ironically enough, the answer is yes. Now, how do you do this? Well, I'm going to use two types of tools, and I could use many more. Okay, there are things like Wireshark and many others that are incredible. For instance, Wireshark can be used to sniff the communication between places, but today we are hacking Windows specifically, so we don't really need that. One of the things that I like to use is a hexadecimal editor called HXD. So this is literally the website it comes from Nexus thing. So search for Nexus HXD. It is free. You can just download it. It's incredibly simple as a hexadecimal editor, but it does a lot of interesting things. Okay, and please remember that it can do different things whether you are administrator or not. So please remember that. But in any case, many of the things I'm going to try, I'm not even going to be administrator or anything like that, and I'm just going to use it. Another thing that's interesting is if you go to sysinternals.com, you get redirected to this place, and this is something called sysinternals tools that was created by Mark Rusinovich from Microsoft. And these include things like Process Explorer, Autoruns, TCP View, and many others. I'm going to show you one or two here, but you can actually download, let's see where this is. So downloads, there should be the sysinternal suite, which includes a whole bunch of tools that you can use. Now, I already have all of them here in a convenient directory, and guess what? They're already here. Interesting things to notice is a lot of these are normal and 64 bits, so 32 and 64 bits. Obviously, use the 64. Just for reference, if you use the normal one that's 32 bits, the first thing it will do is to redirect you to the 64-bit version. Okay, so if you want to run it at startup, if you want to connect it using a script or something like that, immediately go to the 64-bit version. Nowadays, pretty much every computer is 64 bits, so don't go to the 32-bit version because it will start the other 64-bit version and then kill itself. So, it's a waste of time. So always go for the 64-bit version. One of the things that I usually do is I have Process Explorer here. So process. I'm going to use this process monitor here in a bit, but Process Explorer, one of the things that I like to do is to go to Properties, and then from here, I usually say that I want to run this. Actually, not this one. I'm not sure why this is enabled, but I'm not going to turn it off now, but that shouldn't be there, by the way. I'm not sure why that is there. Maybe I did some kind of testing. I'm not sure. But one of the things that I usually turn this on is run as administrator, because every time I start it, I always want to get that message saying, oh, do you want to run this as administrator? And I want to say yes, because otherwise I'll be limited in what I can see, and I want to see everything. It's not very destructive other than being able to kill processes. But, I want to see everything. If I'm there, I want to see everything. But we'll get to that in a second. So we have all of these tools. Let's talk about some of these tools right now. And I'm actually going to start. So I have my, Edge that I use every day, because I wanted to make sure that I'm running this in an isolated environment. I actually have a sandbox user, and I'm going to start Edge on a sandbox. Okay, so I don't care about this update thing. I'm actually here, and one of the interesting things is I really don't care what I'm seeing here, but give me a second, let me just shrink this for a bit. Sorry about this. Screen is smaller than usual. Okay, let me just go and open up Process Explorer from sysinternals, and this is usually what you get. You can customize the columns, etc. For instance, one of the things you should always do is to make sure that this verified signer column is here, because if it is verified, that means that they checked the executable file and the files inside, and make sure that they actually match the digital signature. So that means you are running legitimate things. Sometimes there's one or two that doesn't say verified, so some of these don't say it, but there is a reason why these don't, because these are so internal that you don't have access to it. They are locked from Windows, so this thing is simply blank. But in a normal situation, if you are running this in a different computer and looking inside, you should be able to see this. So all of these, as you can see, say verified in most cases. This is actually good. A few of them do not. One of them is the antivirus. So in this case, Windows Defender. Same reason. So it is higher privileges. So you cannot see it deliberately. But you have many others that are actually useful. Now, if you see here, one of them is username, and I have my normal user, but then I have this sandbox user that I just use for these kind of demos. And pretty much it's empty. I created this for the last time I ran this, so it's pretty much just empty. But what I'm going to do is, okay, so apparently I have, give me a second, I will copy this from here. I have just a simple thing. So one of the things that I already have on this computer is that I created a user and a password. I'm just going to submit it. Nothing wrong with that. This is somewhere on the internet. Doesn't really make sense. But yeah. So I have a password here. I hate bugs. I'm going to copy this one for a bit. And what this means is that there is a bug in Edge that actually tells me that I can see all of the users and passwords that are memorized. And obviously that is incredibly dangerous. So, what should I do? So the easy thing is, if you are the only one with access to the computer, if you are able to trust the software that you installed, in most cases, this will not be a problem. But if you are someone that keeps installing and uninstalling a lot of different software, one of these might actually start to sniff things like I'm going to do in a second and become a problem. Okay. Now, I am going to run this. This is AJAXD. I could run it as the sandbox, okay, but I will actually run it without being on the sandbox user. Now, trust me that if I run this as the sandbox user, you will see the same demo, but I'm literally going to run it as a different user, okay? This is deliberate. So I'm just going to run on my own user, HXD, okay, and I'm going to run it on my own user. And just to be sure that I'm running this correctly, oh, give me a second. Let me just close this off. I'm just going to put this here. And just to make sure that I'm running this correctly, where is this? Okay. I will click on this target thing, which actually points to AJAXD. And then I can see that the AJAXD is here and it's running as user Andy. Okay. Remember, this was not run as administrator, so I don't have any special powers, but I'm going to try to attack the other user. Okay, and vice versa also works. So it's not because my user Andy can actually elevate itself as administrator, although I didn't do it, but it's just simply these are different users. Even with low privileges, they still work. Okay, so I'm going to attack this edge here, and this edge process, the main process is actually 9080. So this is the stuff that I need to know. I don't need this one, and I don't need this part other than the users and passwords that we've already seen. So I'm going to go to Tools, Open Main Memory. Again, I am in a different user. 1 second. This showed up on my other side. So let's go here. And so 9080. So it's actually this one, okay? I don't need the trash that I cannot read. I just need the trash that I can read, okay? So now I am here, which is perfectly fine. Let's increase this. And I am seeing the process in RAM memory. So this is literally the memory that's being used for the process. If I go and find Kafka at this, so this one, let's put this in uppercase because it is uppercase. If I say search all, or actually I could search it, you can see that I have a lot of different places where I can see this. So some of these are the actual passwords that are memorized. Others might be just because the window is open with this at this moment, and that is also in memory. But it is a problem, right? Because this password is hidden, and it should not be in plain text in RAM memory because people can find it. But finding users is fairly easy. What about finding passwords? I hate bugs. That's the passwords. If I click on OK, great, I have one. This one seems to come from the HTML. That's probably this thing next to password, etc. So it is probably, let me just get rid of this one so that I have more space. So this part here is probably being associated with that visual part. But if I click on one more, so currently I only have this one, okay? So technically this might be in one of the other processes that we see. But one of the interesting things is, if I just close this and start it again, and trust me that this actually works, even without opening the page, because it might be a bit biased because suddenly I open the page and I have this string here. If I just open Edge without even touching the actual page that needs this, you will see the passwords. You will see this user and other information as well. Okay, so this is something that you need to consider before you actually run this. Okay, so nothing wrong with that, but Microsoft says it's not a security problem. I kind of disagree for obvious reasons, but it's not a critical thing. Okay, just for reference, let me mention this because this is very important. If you try this with Opera, the exact same thing happens. If you try this with Firefox or Chrome, I assume, I haven't tested it, but I assume the same thing will also happen as well. Why? Because you assume, and this is a very big problem, you assume that when you are in RAM memory, that you are kind of protected, that the processes are isolated. None of the processes are isolated, okay? You can see inside the other process if you want to. And in this case, my user, which is here, this user that you see here, which is HXD from a certain user, is actually looking inside this process from the other user. Okay, so please bear in mind that this is actually possible. Let's see if they fix this bug. I'm not sure if they will, to be honest, but let's see. In any case, this is something that should worry us all. Okay, so let's see one different thing. So another thing that we can do is we can go here to a simple command prompt, not administrator, and there is something called Windows Subsystem for Linux. Now, if you're not familiar with Windows Subsystem for Linux, you can actually go to the Microsoft Store. So go to Start Menu, Store, etc., and you can actually install Windows Subsystem for Linux and then install distributions. So if you go for WSL-L for lists, you will actually be able to see the lists of all of the operating systems I actually have running, not running, but actually available here. They are not necessarily running. To actually run, I need to actually start it, and that will take a few seconds. So while that's happening, I will explain this. So I have Ubuntu, I have two Alma Linuxes here. Actually, these last two are broken, but let's not go there. But in any case, when this starts, it's kind of a container. Think of it as either a container or a virtual machine. But the idea here is we assume that at least it's a container, that it should be isolated. Windows Subsystem for Linux version 1 was actually being able to be seen from within Process Explorer, and I would actually be able to see all the processes individually from here that actually started on that one. So I'm not sure where this one is. Let's see if I can find it, but it is somewhere here. Okay, so it's going to be one of these ones. Okay, so this one or this one will be the one that I actually want. Okay, so I'm not sure which one, but we'll check it out. Okay, so I am entering here, so this is fine. I'm just going to say a very simple message now, just echo something. Okay, and what I'm actually going to do is trying to copy this whatever. Well, 1 second, trying to copy this whatever into my wait a minute. I will actually try to, so if I try to find this, I'm only going to get the console, but I need to attack either this one, or this one. Let's Let's try this one. So 9936. Okay, this one has died in the meantime. This is normal. Open main memory 9936 something, right? WSL is 19936. Could be this one, could be the other one, I'm not sure. Okay, I can never remember which one it is. Okay, so it's not this one. What's the other one? So let's by the way, there is a bug with this. If you try to sort by process name and process ID, doesn't really work that well. It's some kind of weird bug. I don't know. It doesn't really sort it alphabetically. That is actually a problem, but anyway. And this one actually froze. I don't know why. Okay, so sometimes this happens. Let's hope that this is okay. If not, I will restart the process and it's just easier. Okay, let's do this. Since it seems to be taking up a lot of memory, I just press delete and suddenly this is one less process running here. AJXD. Okay, again, I'm not running this as administrator. Okay, I could, okay, but I am not. Okay, and I'm actually gonna put this here and then go to tools, open my memory, and let's see if I can get this here. Seems to be taking a bit of time, so this freezes for some reason. Let's hope that it's not a bug. It probably is. So it probably is a bug. This is a very strange bug, but anyway, sorry about that. You know, live demos have this kind of problem. Okay, so I need to look for WSL, and I tried 9936. Now I'm going to try the next one, and I'm not sure if I'm going to find it here, but I will try. So finds, and then this one. Okay. Nope, can't find it. By the way, one of the things that you might want to do is to use Unicode here, okay? So it might be available in one or the other. So sometimes it's not both, okay? It's either one or the other. One has one byte per character. The other ones have 2 bytes per character as Unicode, of course. Okay, so if it is not this one, let's hope I will try one last one. So this one is already that one. This one is 3000. You know, one of them will have to be the right one. Okay. Nope. Find. And let's try it without Unicode. Nope. Okay. Not very happy at this moment. Okay. I will make one final try because, yeah, okay. I don't want to give up that soon. I've done this one. I've done this one. This one, 88. Let's try this last one. Find. Okay. No. Okay. So, for some reason, I'm having some difficulty doing this demo. Oh, here we go. Okay, so here we are. So I already have this text here, okay, which basically tells me that whatever I wrote is already visible here. Now, this might be active information that's here or just be memory trash, okay? What is memory trash? Oh, I used a part of memory to use some variables and things. Then I deallocated the variable because I didn't need it. I moved on, but the memory doesn't get cleaned. The memory still has the information, the strings, the passwords, whatever bits and bytes are supposed to be there. Okay, so they are still there. Apologies for taking like 3 or 4 processes to get to this point. Now, this Windows subsystem for Linux is really good because one of the things that you can do is you can, first of all, you can run it like this, and it is on this computer. The other thing that you can do is just have a look. For instance, if you go for Kali Linux, in the documentation of Kali Linux, they tell you how to use WSL to actually run it as the equivalent of remote desktop, or to actually have X Windows from the Linux graphical interface, and those windows will actually integrate with the Windows from actual Windows the desktop window manager from Windows itself. Okay, so you can actually give it a try. The best documentation I have for that is go to Kali Linux. They have any information how to use WSL. Okay, how do you turn this off? Well, very, very simple. All you have to do is, because this is actually currently running, all you have to do is to say WSL T for terminate, and then Ubuntu, because I was actually running this Ubuntu. Otherwise, it will actually occupy 1-2 GB, whatever the size is. Okay, so we are mostly done with this one. Okay, let's come back. So what is the problem? Well, the problem is that this one, and of course containers in general, have a very big problem, which is you can actually have a look at the memory. And by the way, this is not limited to Windows. Linux has the exact same problem. Okay, you can actually look inside the memory of a different process. In theory, you shouldn't be able to see processes from other users, but the reality is you can. Okay. So anyway, one of the workarounds, if you are doing the programming yourself, is to actually use something called system.security.securestring. This is not new. This has been around for 20 years or something like that. And basically what you do is you can actually create a new a variable that says secure string, and then you can actually give it the value of the string that you want and then clean it up. Or you can still add the individual characters one by one so that it doesn't stay somewhere in RAM memory. And then when you want to read it, you can even, run the secure pass variable here in the middle of a process or other variables, and they will extract character by character or something like that. But this will be it's not encrypted, but obfuscated in a way that it is difficult for you to be able to recover it. Okay, so this has a few years of experience. And by the way, for the secure string class, there is going to be a dispose, which eventually will always happen, that will go into all of these memory positions and actually clean it up so that no leftover of that password is actually available. Okay, and that is very important. Okay, so elevation. I tried all of this without elevation and it worked. So I wasn't the administrator. Please remember that there aren't two levels. There are many more, okay? We think that there are only two levels of elevation, but there are many other levels in between and many other variants of levels as well. Just for reference, if you use user account control, it is a good idea because you don't want to run everything as administrator like with the minimum option, because that is just dangerous. By default, Windows is usually here in the number just before the maximum. My recommendation is always put the maximum in. Some people actually prefer to create a user for themselves and then a user of themselves as administrator, so that the normal user will never have administrator privileges. Even if you say, oh, do you want to run this as administrator? Yes or no. How many times you have a yes or no thing that doesn't have a password, and suddenly you say yes accidentally because you just want to run it, and then you remember, oh, wait, I said yes to what? What was running as administrator? Did I start something as administrator? So it is a danger if you get used to just saying yes to those kind of things. Eventually, you might say yes to something that wasn't triggered by you, and you have a human reaction to just say yes. In any case, notifying always is the best idea, so that anything that happens that might affect the computer from an administrator point of view will always be notified to you, and that is the safest way to do it. No program that runs just for your user should actually ever request administrator privileges. Okay, for instance, I run I don't like Opera, I don't like Chrome. They are very dangerous in terms of stealing your data. They steal a lot of your data. I use Edge, which is okay except for this small problem apparently. Firefox is kind of okay, but there were a few versions that did have leaks. But in any case, it is for me, it is not acceptable for me to install Chrome or Opera or something like that for everyone. When I install any of these kind of programs, whatever they are, I install them for a specific user, okay? Which means that I shouldn't have to use administrator privileges to actually install the program or even run it. Okay, that's very important, which means that I have a few different users which are sandboxes, and all of them run independently. At least that's what we expect. Okay, except as we saw with the RAM memory that is kind of shared and it could be a problem. Okay, now there is a software, and this is literally what I did. Give me a second, I will show you here. So this kind of thing that you see here is actually a command, is a shortcut for a command that I'm going to show you. And you can run a command. This is the example if you wanted to use Opera, and it would probably show up somewhere similar to this. It doesn't have to be exactly this, but you would run the runas.executable file, and it's typically on system 32 as always. It's a good idea to put the full path, because if you don't put the full path and you have something else in the path before called run as, you're going to execute that one first, and that could be something trashy. Okay, so you always put the full path there, especially if you are running Windows things that have, require elevation. Otherwise it's going to be complicated. Anyway, you can say /run whatever the user is, /user whatever the user is, and then say /safe credential. Okay, what does this mean? It means that the first time you enter the credential, second time it's already memorized, and this one is safe, so no worries, and next time you don't have to do it. So when I clicked on those shortcuts, the password for that specific user on my computer was already memorized, so I didn't have to do it again. Okay, so it is practical. You can automate this, you can run this. If your machine is used for a lot of testing, you can still test it safely, but still don't be bothered by having to enter a lot of passwords all the time. Okay, but please be careful, because safe credentials should be used in an environment that you can fully trust, not an environment where accidentally a lot of other things might run, because someone else might actually try to use those credentials just by running a script like this. Anyway, the Opera here, for instance, is in the drive C users, some user, update, etc., and this executable file is local for a user, not for the whole computer. Okay, and this is important. Okay, now also continuing on the memory situation, about was it 9 years ago? No, 8 years ago, maybe 8 years ago, there was something called Spectre and Meltdown, and these were attack techniques that happened. I remember this happened around January a certain year, 2018 or 2019. I can't remember exactly, but it was one of those before the pandemic. And this was difficult because for 1.5 months, 2 months, all the cloud providers were actually working to fix it. And the only way they could fix it is to turn off the optimization that allows this kind of attack. And with that, all the cloud services became slower by about 20%. Now, this is not a problem that was local at the time. This was a problem that affected chips that came along from 20 years before and even older. Any new chip that's current now might still be affected by this, because this was not a change that you would do from one day to the other. This was structural. This was attacking something that was used for optimization. Okay, and I'll show you exactly what that is. So this is the example. Think of this as assembly. This is obviously this is pseudocodes, okay? But think of this as assembly, as a very low-level thing, okay? Now, let's say that I want to run these operations to say variable t or memory position t, or actually register t on the computer, if you prefer, on the CPU of the computer. Temporary register t is equal to a plus b, and then u is equal to t plus c, which is dependent. So there's a dependency from one to the other, so they cannot run in parallel. And then v is equal to u from before plus d. Okay, and then what you're going to try to do with, if v, let's say that v was just a boolean of true and false, for instance, or zero non-zero if you prefer, it doesn't really matter. This is just a proof of concept. And if v is equal to true, which might not be true, You are going to say W, which is yet another variable, is equal to going to be the kernel memory of a certain address. And this is the address that you might want to hack, okay, to find out what is written on that memory address. And then what you're going to do is to do W and then AND, the operation and extract one single bit, okay? And then you're going to try to get that from user memory, okay? Now, so far so good, but if you are getting things from user memory, it's usually easy. But if you try to get it from kernel memory, in that case, only if you have permissions will you be able to go there, okay? Which is not always, okay? So here is the optimization that most CPUs and most compilers will try to run, okay? And this is what fails. So what you're going to do is TU and V get processed as A plus B, T plus C, U plus D at the same time as W, X, and Y, but underscore, so a different one, actually gets equal to that part there, which basically is running this one and this one at the same time because they are not dependent on each other, okay? However, I will not be able to know if this kernel memory, actually this one here, will actually be successful or fail because there is a pre-requirement here of V that hasn't been completed yet. So I'm assuming that I have that permission, I will be able to get this information. But if V and it fails, it will give you a false. Okay, so the idea here is that it will not give you a fault there because you got there in an easy way, but it will fault it here. But this will already run. So this is one of the ways that you can hack this. Why? Because you see this user memory here. The trick of that user memory is that you can actually discover if the result of X is equal to 0 or 1 as a bit, as an individual bit, and you are doing this bit by bit, not byte by byte. It's literally bit by bit. So within the address, you have to do this 8 times, bit by bit, okay? So what actually happens is that if you get here, there is a fault, but what will actually happen is if you are able to get a 0 or a 1, depending on what was predefined, you are able to determine if there is a caching for the value of 0 or 1. And for one of them there is, for the other one there isn't. And the difference is a few milliseconds or microseconds, which the attacker will measure. So the attacker will measure the amount of time that this takes to run. Whether this is at fault or not doesn't really matter, okay? But it will measure the amount of time, and then it will determine, based on the amount of time, if it is a 0 or if it is a 1. And then you repeat this a million times, 8 times for every byte, and then the number of times for every single memory position that you want to sniff. Now, this works so well that it kind of ignores if the memory position is yours or from a virtual machine in a virtualized, isolated environment like a container, or virtualization extensions from the CPUs that actually protect you against this. So they will still be able to find this information. This is why Spectre and Meltdown were dangerous, because in a cloud environment like Azure, like AWS, like Google Clouds, you would be able to see everything that's on everyone else's machines, okay? Which is obviously a very big danger. Now, if on the physical machine you're only running your own things, this is not really a problem. If you are sure that no one's installing things on the machine, this could be a SQL server, this could be something else. In that case, you are perfectly safe. Those optimizations can continue to exist, and no one's is attacking it. They might fail or not, but these are normal, no worries there. But if for some reason other people are have virtual machines on the same physical machine and they are not under your control, then it is a security risk. Okay. Anyway, within Windows, and by the way, this screenshot is slightly old, although it's kind of okay, still checks out. So here, if you go to settings and go to some of these advanced things for Windows security, somewhere, device security, something like that, you'll actually get core isolation, security processor, etc., and a few other things that modern Windows 10, Windows 11 will actually have. And these kind of isolations actually protect you against these kind of problems. Okay. For instance, one of the isolations that is ideal for this is if you have two virtual machines, half the CPUs go to one virtual machine, half the CPUs go to the other virtual machine, and then the caching hopefully will be isolated as well. Okay. There are hardware that allows you to isolate the CPU cores between them. Maybe not a normal PC computer, but more advanced computers will be able to do that. Okay. Anyway, let's move on to something a bit more. Okay. Now, this one is very, very different, but it could still be a security risk. Okay. So let's say that you are playing around, you have all of these passwords from Edge or from somewhere else in memory, in RAM memory, and suddenly you need to store, you need to hibernate. Okay. What is hibernate? So if you turn off the computer, the RAM will die. That's easy. If you sleep the computer, so if you go here for Windows, give me a second. If you go here for Windows, shut down the computer. If you say sign out, that's just sign out. Sleep is actually suspending the computer. Shut down and restart, just kill the RAM memory and you start again. But there should be a hibernate there that I turned off, okay? Because I don't need it, I don't use it, okay? So what is the hibernate option here? Well, the hibernate option allows you to use the possibility of copying the RAM memory. In my case, it's 16 gigabytes. They will copy all of them to the disk, and then they will turn off the computer. Okay, it's like a sleep or suspend, same thing, but hibernate actually turns off the computer, turns off the RAM, turns off everything, but the RAM is still there. So when you start the computer again, they will load from disk all of that RAM that was spending, and they will put that back into the RAM memory so that you can continue exactly where you left off, like a suspend, but without spending battery. The bad side of this is that to start it and to stop it takes a few seconds to actually read and write from the disk. Okay, so that is kind of a bad thing, but that could also be a security risk because you are writing to the disk all of that information that should be confidential. Okay, even though you might have BitLocker and things like that, it is still a security risk. Okay, so I would recommend Power CFG, which is the power configuration options. Turn it off. That is always the best option. Okay, if you use sleep or suspend, if you prefer, it keeps the RAM alive. So yeah, in any case, there is something that you can go, which is available sleep states. Okay, in this computer, let me just mention that in this specific computer, give me a second, let me just start the CMD prompts. Give me a second. My computer is incredibly slow because a lot of things are running. So Power CFG, okay. And then, wait a minute, I'm just going to be very lazy and do copy pastes. Available sleep states /a is okay. I don't need to do the whole thing. So in my case, I have something like low idle power. Okay, and that is even worse. So depending on my computer, usually you can't have both. You have an S3 where you turn off the computer, etc. Either one of these, but this one doesn't support it. So in this computer, I have low power idle. What does this mean? It behaves exactly like a phone. Even if you suspend it, it is still, not only is the RAM valid, but the CPU is still running, the network is still running, and it's kind of a very low power mode, still consuming battery. But it's like if I do remote desktop into it, it will start, everything will work. It's just the same as a phone. It never turns off. A phone is S0 low power idle. But a normal computer will actually suspend itself if it uses one of these, typically S3, S2, something like that. Okay, but this one is interesting, but it does have a lot of drawbacks. So, when you buy the computer, you never really know which one you're going to get. But yeah, I think nowadays they don't have many of these, and this is not something that you can change because it's hardware related. Okay, anyway. But these are interesting. So this is like a mobile phone, as I mentioned. Okay, if you have things still running, and if someone steals your computer and opens it up, they can connect things to the chips, like probes to the chips, and actually detect all the bits and bytes that are going on in there. So while it is sleeping or while it is actually running, you will be able to get hacked in terms of memory. Okay, not very typical, requires very expensive hardware, but it is possible. Now let's talk about sysinternals tools. One of them is Process Explorer that we saw before. Let me just show one or two more things very quickly. 1 second. Okay, so you have a lot of different processes, but what if I want to see something about this process? I can actually double click on it, and oh, you went to the wrong sides. 1 second. And you have the properties for all of this. Properties can be all of the contents. Apologies for this not fitting on the screen. Performance, so you can see all the performance of this, graphs as well, etc. But there are interesting things coming along. So all of these performance, GPUs. Threads are interesting, so you know what's running inside of that specific process and give a lot of information. Technically, you can even kill one of the threads if you feel that's slow, but that will pretty much destroy the whole process. So you shouldn't be doing that. You can actually see everything that is actually connecting at this moment to the internet and all the connections that are running. You can also see security. This is running under a certain username, in this case Sandbox. We were trying Sandbox before, it's still there. So this ran as the Sandbox, as you can imagine. In terms of environment, there's a lot of different environment variables that are here. In this case, drive C, user, sandbox, whatever, it's expected, but every process has this. In terms of jobs, there might be jobs here associated with the thing, but also strings. So the hardware, the executable file, the actual executable file will have a lot of different strings on the actual thing. So if you look with an hexadecimal editor, look inside the hexadecimal file, you will see all of these strings that for some reason are used for something. If they are in plain text, you can see them here. I obviously prefer to go to a hexadecimal editor for obvious reasons. Okay, if you double click here, you'll actually also be able to see all of the CPU information, etc. So system commit, etc. CPUs, all the CPUs running. And yes, these are running very high because I'm sharing the screen and doing a lot of crazy things. Okay, so this is normal. And this one is a few more in-outs, etc. So I am able to see all that is happening. Okay, so this is obviously expected. Okay, auto runs is different. So auto runs, let's have a look at auto runs. And I have auto runs here. So I've started it already because it takes like 2 or 3 minutes. And this one tells us, and what you see here, like current version run for logon, this logon will be here. So this one specifically, so everything, logon, explorer, etc. So all of these are things that you are able to see that are running. So when you start the computer, and you log in as the current, in this case, CU, Hive key current user. And when I'm logging in as my current user, which is me, this will start automatically. So if I want to turn off these lists, I can just turn it off, and they will not start. If I want Edge not to start automatically at startup, I will just turn it off. If I don't want OneDrive to start, I will turn it off. Okay, and many others as well. Okay, so other things that I really don't want. So Windows Media Player initialization. Maybe I don't want that. Okay, it's boring. I'll do it the first time I use it. Windows Desktop Update, so some weird things that might be useful or not. You notice that I've turned off a lot of things that I really don't want. Okay, some of these like delete cache, standalone, whatever. I don't know what this is. But OneDrive setup, so this is apparently part of OneDrive setup. Next time I'll reboot, they will probably clean it because it says run once. Once they say run once, they will get killed and run again. Okay, so why is this important? Because in the old days, you would know that if you went to the registry for local machine, for current user, etc., and if you went to a specific place like software, Microsoft, Windows, current version, run, you would know that all of these were on startup. Okay, there's also the startup folders here. If you go here for settings and try to go to the startup, you'll also find it, which is fine. But in any case, yeah. So a few things. If you don't like it, just remove it from the lists. Many of these that say file not found, that's because something is wrong, and my recommendation is always to turn it off. This one requires different permissions, so I will have to go there manually to turn it off. But many of these, if they are yellow, I can just say, look, there's a problem with that. I will just remove it so that no one else will actually put an executable file in its place and I run it accidentally. Okay, so this is how things get started. And you have a lot. You have like browser helper objects for Internet Explorer, which honestly it shouldn't be here, but they seem to come back after a while for some reason. And then you have things like auto runs for Opera, etc. This is actually not auto runs. This is task scheduler. Okay, so many of these I don't want running. Okay, for instance, I have OneDrive here on this computer, but I only run it for one specific user, not for all the users. I don't have OneDrive for that sandbox. So you turn it off because you don't need it, and you save a lot of RAM memory. Okay, so there is much more, of course, but then you have, if you go towards the end, you have services, etc. You have add-ins for Office. You have a lot of things, so you can change many of these things here. Okay, one of the things that is interesting is here for Explorer. And by the way, everything is everything. Explorer is just a smaller lists. For instance, here, if you want to go to, let's see if I can find it, this OneDrive symbol that you have next to the files, if you want, you can actually remove it, and it will actually be much faster to actually see things in the File Explorer of Windows. Okay, so it is okay, but some of these extensions actually make the computer slower, especially for some third-party tools that actually, fiddle with this. So it is nice sometimes to go and have a look and see if you can remove some things to make things faster. For instance, if you right click on a file and for some reason it takes too long, and this, as you can see, took a bit of time, that's because there's a lot of trash somewhere here that you might want to clean up. Which one should you clean up? No idea. You have to go one by one to actually decide. Okay, so I want to do one more thing. Okay, so I have here registry. Okay, actually two more things. Let's see if we have time for that. Here, let me just refresh so that people know that I'm being honest here. There's only keyboard. I'm gonna add something else here, and I will actually start my Visual Studio. I have a very small demo. Okay, so I will actually start this demo. Okay, so this is a simple demo. One of the things that we'll do, I will not do that part, which is the same as going to AJXD and finding things. I will skip that part, okay, because this demo originally came from a different place. Okay, so if you go for this connection string, obviously this username, etc., that is on this application, this is an executable application compiled, etc. And of course, I have some kind of connection string here. If I used AJXD to see it, I would obviously see it. I will skip that part for time reasons, but we tried this before. But now I'm going to do something slightly different. Okay, so what I'm going to do next is to actually go for this one. Okay, and try this one. Let's say Putin, and the password will be, okay, something like this. Okay, seems to be famous, this story at this moment. Okay, so now this stopped. This is fine. Okay, so far so good, but now, okay, if I wanted to find it, I would also be able to find it. Okay, now, but let's continue for now. The AJXD part I will not demo again. And now I will try something called process monitor. Okay, so Let's go to P for process monitor, 64 bits, of course. And give me a second, running as administrator, of course. And let's see. Okay, I'm looking, trying to find where the window is. Okay, so please be careful with this one because this one will be very heavy, okay? And give me a second. So when you start this, one of the things that I'm going to say is I want to run this executable file. This is literally that executable file, KGB secrets executable file. I will just say I want to sniff only this one, okay? Because otherwise, if you try to sniff the whole computer, it will be crazy. Now, some of these are useless, okay? But I am ready to try this out. So let's see what happens, okay? So I just found some of these files. So I tried to do a directory listing of drive C, and now it said, oh, I read all of these files. And we know that this is true. We try to read file, read file, read file, read file. You can see the details, but I'm going to skip that one, okay? By the way, it says create file. There is no create file involved, okay? It's just accessing drive C, but uses the create file, term, and then query directory C star, so wildcard, and then all of it, and then close file, which is the close file. So I'm going to use this last file, which is the last on the list. Doesn't really matter. That's how the demo was set up. Okay, I can trash it all so that I can see it better. Give me a second. This is very, very slow because the computer is suffering a lot with slowness. Okay, this computer suffers a lot with the slowness. Apologies for that. Okay, but it is running at a lot of capacity. Give me a second. Still very slow. Okay. Wait a minute. Maybe I will just kill it and start it again. The biggest problem is that I'm running a lot of things and then capturing the screen, doing a lot of things. And this is one of the reasons why things might actually become very, very slow. Okay, so apologies for that. So let me just find that process monitor. Let's kill that process monitor. So it just got killed. Let's start it again. Again, apologies for this, but sometimes when we're doing this live, it is slow, and StreamYard that is being run here is incredibly slow as well. It slows the computer. Teams is usually faster with this, but StreamYard is very, very slow. So give me a second. So now I have this getting started. Okay, so let's, I'm going to just select the same thing. Okay. And I'm just going to monitor it. Okay, so I'm just going to keep it here. And I'm going to see, okay. So I'm going to look at the specific file. So read file with all the details. Okay. And afterwards, I'm just going to go and do the next. Okay. So I was able to, give me a second. I was able to look at the file entirely, and of course the process is looking at more. Now I'm going to do something slightly different now, which is I'm going to go to I'm afraid to click on this button now. One of the things that you see is that registry writing, and you can see it try to write to the registry to the KGB top secret place. Okay, let's go and have a look at the registry. Okay, oh, something is happening. Okay, for some reason it lost the screen. Hopefully this is okay. Some slowness going on there. Apologies for that. Okay, so I'm going to refresh this. And hopefully I have one more. And this one now has the username of Putin. I didn't put the password, but you get the idea. So now what I'm actually going to do is I am able to go and change the username here. So if I change the username like Austin Powers. Oh, wait a minute. Austin. Okay, 007. I don't care. some difficulty there. Okay, so if I go there and change it, suddenly, of course, if you go, oh, it's not this one. If you go and try to see it, next time you try to read it, let me just continue, of course, you will see the registry output will be 007 because I changed it and now it's different. Obviously, registry is an amazing place where you can store a lot of different things and they work really well. Now, I'm just going to stop this because I think this is slowing down my computer like crazy, especially the, the profiling and debugging that thing actually does. Okay, so I'm going to skip that one. I'm going to show you one more thing in the registry, and then for time reasons, I'm going to speed up. Okay, so there are a lot of different, and by the way, and I'm going to close this one as well because this one also slows down your computer like crazy. Okay, so while this is loading and everything seems to be slow, very, very slow, if you go to classes roots, which is actually part of there's current user, there is local machine. Many of these are the same. Okay, they apply either to, for instance, the software part applies the same way to both. Could be here or can be the software here, same software, Windows current version, run, etc. But in any case, if you go here for software classes, this is an alias for this all the way up here. Okay, and if I open this up and look for directories, so dir directory, okay, I actually created something already called hack, okay, hackwin, and I said hacking Windows. And all I'm saying here is that there is a shell object for any directory, okay, and it could be a directory, txt file, etc. It can be anything you want. But for the directories, for drives as well, if you want to, there is something called drive somewhere here, device, another one says drive somewhere. So I go to shell, hack Windows, and then the command, I will say, look, the v parameter is basically the file itself. So what I'm going to do is to try to run this. So where is this? Well, I have an example here, directory example, right click, and if I say show more options, because Windows 11 is terrible at this and doesn't show the full thing immediately, that is actually slow. There's a registry hack, you can just show this one directly. It says hacking Windows. So when you start it, and it's going to show up on my other screen, but when you start it, it will actually say parameter is something, which is parameter is something, which is literally that directory of example, but then it will actually show up here. Even this computer name that I usually have shows up badly because it doesn't have the environment variable. So, it will fail. This one has the actual computer name here. So you can see this is not perfect, but it is useful for a lot of different things. So you can change the right click for a lot of things. Don't exaggerate because it will make your computer slower. Okay. Now, having said that, I want to show just a few more things. One of them is called Power Toys. Okay. Very, very quickly show you Power Toys. And let's see in terms of time. Marcia, how am I doing in terms of time? How many minutes do I have left? Anyway, while this is going ahead, there's a lot of Power Toys. You can download Power Toys from Microsoft website. A few of them are nowadays integrated into Windows, so you don't need them. You can just use the Windows ones. Zoom it, for instance. Windows has a magnify functionality, Windows key plus and minus, so you don't really need many of these. But some of these for me are useful. One of them is this. Where's this? File locksmith, which is if you have a process, if you have a file and that file is being locked by a process, you can right click and say, unblock it so that you are able to do something with the file. It unlocks the file. Okay. Find My Mouse. It's a visual thing. There's a lot of visual things here, fancy zones, etc. I don't care that much for them, but I do care about things like keyboard manager. So my keyboard does not have 3 keys working. So I decided, look, my T is not working, my O is not working, my 9 is not working. So I replaced them with different physical keys. It is difficult in the beginning, but the alternative is having to buy a new keyboard, and that's a lot of work. So, it's a good solution to just use this. But besides this, you also have a few other things like always on top. It's really, really good. I really like the always on top option, which allows me to say, look, if I say Control Windows T, I think it's this one, Control Windows T, if I'm not mistaken. And if I go, wait a minute, it doesn't say noise, Control Windows T for some reason. And then if I go here, well, in theory, it should have worked, but for some reason, I don't know. It just happens to be that same key that's actually not working on this computer. So yeah, it is a problem. Anyway, but there's a few other options here that are actually very, very useful if you want to use it. Registry preview, power rename if you use it a lot, etc. But many of these, as I mentioned, come with Windows nowadays, so you don't have to use all of them. Okay. Now, just to wrap up a few things so that you know this, there are a lot of different things here that are useful. Disk to VHD allows you to take a disk, a normal disk that you have connected to the computer, and you can replicate it as a VHD file. And that is actually incredibly useful. So let's see if it pops up. Again, my computer is running this very, very slowly. So it takes a bit of time. Here we go. Okay. So disk to VHD. So these are my partitions on my single disk. There's only one disk at this moment. And I could actually save this as a VHD file. Okay. Before I do that, there is a recommendation. Let's say that your computer had virus. You would be able to use disk to VHD to actually create a VHD image of your computer and then take it to a sandbox environment in a virtual machine so that you would be able to test it and play around with it and find the bug, find the virus, whatever. One of the things that is actually good for you to know is something called sdelete. So this sdelete allows you to do sdelete/z and /c allows you to clean up the empty space. And it is a good idea to run this before you actually copy to the VHD so that it shrinks the size of the VHD, so the empty parts don't get copied as well. So these two actually go very, very well together. There is a lot more, so things like the junctions and many others that are actually used for this. Okay, so you can use them, but given that we have limited time for this, it is not something that we have time to see all of them. Let me just show you one or two very, very quick. So TCP. So where's TCP view? TCP view is good. So you are able to see all of the connectivity on your computers like netstats. Okay. There's a few others, but I'm going to skip that one for now. Okay. So the TCP view allows you to see the same as netstat, but in a live kind of situation. Marcy, how are we doing in terms of time? We need to wrap up, right?
Yeah, sorry, I just joined. Yeah, you asked me before, I couldn't unmute myself.
Okay,
Yes,
okay.
so 14 minutes over.
Oh, no problem, no problem. Okay, let's wrap up this just 1 or 2 more minutes. So you can see that these are some of the processes somewhere, and process ID something, and these are connections going in and out, so you can use them and look at them here. Very, very practical. Okay, I need to wrap this up. These are some of the examples that we saw. Okay, another one is PS ping. So you can do PS ping. By the way, this one I definitely need to demo. Sorry. I definitely need to demo this one. So let's say, why is PS ping important? Because while we do a normal ping, and let's say you are pinging my website, you can do that. But what, and this is actually in Azure, but what if I don't want to ping the website? What if I want to ping the actual server? And this will be 443, okay? I would not be able to do it like this. However, if I do it like this, oh, wait a minute, PS ping. Actually, wait a minute, PS ping. nd.pt like this. This one I can do. And you can see how fast or slow this is. So if your pings and ICMPs are closed, this one is a good solution for this and still tells you how long it takes. So I use this quite a lot. PSPing is one of the most valuable tools that you can actually have. Okay, there are many others. I've mentioned SDelete, Disk to VHD. We talked about Process Monitor and Registry Editor. A quick reference to WinMerge and WinDiff. WinDiff is quite old, but they actually compare files. So if you have multiple copies of files, and if you want to remove the duplicates, I usually like this, but they're also good for forensics if you have the original disk and you want to see how the virus is acting up, and then you compare the file system between them. Once that happens, you compare the original with the results, and you are able to see where it actually attacked. Okay, so we saw the registry as well, so nothing special here. And remember, there's local machine, current user, etc. Okay, and there's also all the other users, but usually you stick to your own user. Okay, by the way, there's also classes root, and there's a few others that actually are about managing the computer and monitoring, etc. But I didn't include those. Okay, we also talked about WSL. Okay, WSL2 is the current version. It is a bit better, although there are things from version 1 that I would prefer, but obviously we're going for version 2 these days, but they are different. Okay, see the Windows integration, visual integration, those look very good. Look for the documentation in the Kali Linux websites. Okay, those are really good. Okay, just one final curiosity, which is this one, which is this is actually a Linux machine running inside of a PDF. Okay, the link, I'm not sure if I have the link for this. No, but the link is here, github.com, blah, 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 blah. This is a PDF running inside, that inside runs Linux. Okay, so you can look it up on GitHub to actually find it. Anyway, we need to close this off. I know that there are many more demos that we could try to do, but sadly, for time reasons, we would be able to stay here a whole week doing demos, but some of these need to be selected. Anyway, if you are familiar with older versions of Windows, you'll be familiar with this. I'm not sure if any of you have any questions, but I'm always happy to answer any questions that you might have. Let's see. I don't see any questions here in the chat, but in any case, let me just thank Cloud Lunch and Learn for the opportunity to show the session. So it's always nice to be able to hack something online for lunch. Okay, please don't get arrested. So use this for useful things. Don't use this to get arrested. And feel free to reach out on LinkedIn, any kind of social network. And yeah. Thank you very much for being here. Marcia, thank you very much for moderating the session, and hope to see you next time. Okay. Thank you all very much,
Thanks,
everyone.
everyone, and have a lovely day. Take care.
Okay. Thank you. See you next time. Thank you very much.
See you. Bye-bye.